For 4, we're not solving these. We just need to know which proportions or how to write a proportion. Okay, and this one is dealing with the triangle proportionality theorem. So remember, that one says whenever we have a side DE, or a segment DE, if a line parallel to one side of a triangle, so they tell us DE is parallel to BC, so I know those two are parallel, intersects two other sides of the triangle, then it divides it proportionally. So this one, which is DE, is going through the triangle, and it's cutting these pieces, it's dividing it proportionally, which means we can write a proportion out of it. Okay, so here we have CE. CE is this side, CE, and then on the bottom of that they wrote EA. So over here we have to put the matching ratio or proportion. If you look, CE is these 2 points. Well, that's going to match up with these 2 top points, BD. So here you would write BD. And then EA is these bottom ones. Well, that matches up with DA. Okay. And that's all we're doing there, is finishing the proportion basically. You just have to know like there's 4 pieces, or there's 4 segments, and then you write it, this one divided by this one divided by this one. But remember, you can go across this way also. Okay, let's see how it is over here. So here it says BC is parallel to DE. So again, this side is parallel to this one, and it's cutting, it intersects the triangle. Okay, so when it intersects it, it breaks it up into 1, 2, 3, 4 pieces, and those side lengths, or those pieces, are proportional. Okay, so here we have BE and EA. Okay, so they put BE and then EA. So BE on top, that means that matches up with CD. BE matches up with CD. Okay, this segment matches up with this segment. And then the other one is EA. Here's EA. That one matches up with this segment, which is DA. Okay. A little bit different than the other one, but still same idea. And then finally, number 5. Number 5 says, set up 2 different proportions to find the length of KN. Now if you look, KN is this bottom length. And because they're talking about this bottom length, I can't necessarily use the triangle proportional theorem. Okay, what I want to do there, or what we should do there, is separate these and say this is KJN, which is 9 over 15, or 9 and 15 in the next. So this is the top triangle that I just wrote down. JKN, JKN, and then the other triangle, the bigger triangle, the one that goes from J to L to M. Okay, JL is 9 and 3, which make 12. L to M is 28. And then J to N is 15, 20. Okay. So those are the triangles pulled apart. Okay, now you want to pull them apart because you want to find this bottom length. And you cannot use these proportions like that. These proportions are only dealing with these side lengths here, the side lengths that are cut. Okay. So to write 2 different proportions to solve this, We definitely need to use the x and the 28 because those are corresponding. The x is matching with the 28. So we definitely need to use that if we want to solve for x. Okay. Now then it's like, okay, what if I want to use the 9? If I choose this side length over here, well, 9 matches up with 12. Okay, and the 9 and the x go together, and then the 9 and the 12 also go together. Okay. See, the top ones are both coming from the left triangle, and then the 9 and the 12 are corresponding. So that's one proportion you can use to solve this. Another proportion you could use to solve this, let's say we don't use the 9. Let's say we use the 15. Let's say we use the 15. This side. Okay. Well, the 15 matches up with the 20. So then it would be 15 over 20. So those are two proportions to solve the same value. Okay. Now watch, I'll show you it gives you the same thing. So here we would put 28 times 9 divided by 12. 28 times 9 divided by 12. X 21. So let's do it over here. 28 times 15 divided by 20. 21. Same thing. Because it's the same answer, I know I can use either one of these to find x.